Hello, my name is Megan Longoria with Procure SQL. Today I'd like to talk to you about Azure Data Factory for each activity parallel execution. Let's say we have a collection of work to be done in Azure Data Factory. Each chunk of work uses the same activity type and has the same inputs. Each chunk has varying expected durations and resource usage. The work may be executing another pipeline, or a copy activity, or a stored procedure. If we were to execute this serially, let's say it takes 94 minutes. Now say we decide to run it through a for each activity with a batch count of 3. This means that at any given time during the execution of the for each activity, there are at most 3 child activities running. But it doesn't guarantee that 3 are always running. Let's talk about why. Before a for each activity is executed, the inner work is assigned to internal queues. But ADF doesn't have any information about the resources required or the expected duration of the activities. So it may assign work in something of a round-robin fashion. This results in queues that can be rather uneven in execution duration. For simplicity of explanation, I'm assuming that the time it took to execute the activity doesn't significantly change when the activities are executed concurrently, which may or may not be true in your environment, so please keep that in mind. So Azure Data Factory has created these internal queues, which we can't really see, but I'm depicting for this explanation. And we have 2 queues that will take 18 minutes to execute and one that takes 11 minutes. That gives us a total duration of 18 minutes, which is better than the original 94 from serial execution, but it also will take more resources on the target compute, so please be aware. Let's see what happens during execution. You might have noticed at the end there that there was an empty slot in the middle where the second queue had completed. The first and third slots still had active work, and there was one activity left to be executed in the third queue. You might think, well, that last activity can go into the second slot since it's empty. But that's not what happens. This is because for each activities do not rebalance the work in the internal queues once the execution has started. So that last activity stays in the third queue and waits to be executed until the work that came before it is done. Now, given the information we have about expected duration and resource requirements, we might be able to make more even queues. We could create something that still has a batch count of 3, but results in 2 queues of 16 minutes and 1 queue of 15 minutes. So we get a total duration of 16 minutes. Same work, just different distribution of work. But how can we make that happen in Azure Data Factory? The answer is to pre-assign the work to explicit queues and use multiple for each activities. I can use 3 for each activities in which the inner activities are executed serially, but the for each activities themselves are running concurrently. This gives us our 16-minute total duration, which is an 11% reduction in execution time. So what does this look like in Azure Data Factory? We start with a configuration table or file that contains the activity inputs, as well as an additional column that is that explicit queue assignment. For each row, in my case it's another pipeline that's being executed, I'm assigning the row a value of 1, 2, or 3. And I've assigned those values, usually based upon average or expected execution time for that activity. So I did the math, usually in SQL, to determine the optimal queue to even out the durations of the for each activities. And the filter activities accept only the work that belongs to the subsequent for each activity. So if row 1 in my config results is assigned to Q2, it gets filtered and assigned to the iterate tables Q2 for each activity. Now, this is highly dependent upon the work to be done and the resources on the target compute, so your time reduction can vary. I've had the time savings be as little as a minute or two and as much as a couple of hours in the projects where I've implemented this. You'll have to decide if this is needed. I don't do this for every parallel execution scenario, but when I need to achieve more predictable execution times or meet an SLA and reduce my execution time to ensure the pipeline completes by a certain time of day, for instance, this is an approach that works well and can be templatized. Thanks for watching, and I hope you enjoyed this Azure Data Factory tip.